S is side, A is angle. They're postulates, but you don't have to write the word postulate. You can just say SSS and SAS. Oh, and I'll say this one's SAS. This one, I just SSS. SAS for that one. Yeah, so you could make a snake sound if you like for the first one. So I'm going to come back to this vocab word. First, let me go right down here. And here they are. These are two shortcuts. So SSS means I don't need all 6, 3 sides, 3 angles, all of those. I only need 3 sides to be congruent between the triangles. So if you have 3 sides of one triangle congruent to 3 sides in another triangle, the triangles are congruent. There's a diagram down here. It's in the box here on yours. But yeah, you only need 3 sides. So you could have nothing but the angles. If you have the 3 sides, what it means is the angles would then be congruent as well. It's just, yeah, you have enough information. Okay, there's only 2 exact triangles that could be formed if you have 3 side lengths between the triangles congruent. And then the other one is SAS, SAS. Now, so this one you need 2 sides congruent between the triangles and 1 angle. Now, the thing about the angle is it's between the sides, which we call an included angle. That's simply the definition of an included angle. It's an angle formed by 2 sides of a triangle. So in the example here, I said, all right, consider PR and PT. Then the included angle is angle P. So there's 3 angles in a triangle, that only one of them will be included for 2 sides. So if it was R or T, it would not be the included angle. So if you do have that, if 2 sides in the included angle are congruent to 2 sides and an included angle of another triangle, then the triangles are congruent. And there's another diagram right there for you. So it has to be the included angle. Now, before I'm going to let you guys try example 1. I think on the next page. Yeah. I found this, and I thought it was kind of a nice diagram, because it's a new concept, but I bet you've actually done or seen somebody do side angle side before. Here's why. It's kind of a silly example, but it's true. Have you ever been moving something like a couch or a box, and you're trying to see if it can fit through a doorway? Or it doesn't have to be it doesn't have to be a doorway. It could just be does this fit through in a window or on a ledge or something? Have you ever just done this? You stood there and like lined it up with your hands and then gone over it? Anybody do that?
Nope.
Like you don't move.
I always
Yeah, exactly. I've done it so I don't have to get out like a ruler. Or
No, I use
Oh, I definitely.
Oh, no. So you see this person, they try to move the box, they just go over. So what they're doing, the angle's not changing if they keep this steady, and then their arms are not changing length. And so they're using congruent triangles to say like, this is how much, this is this length, and they move it over here, and it's the same length, and seeing if they can fit it. It's a silly little example, but it also kind of shows, yes, you have done this before, or possibly seen somebody do it. So, any initial thoughts though on SAS and side?
What?
I'm looking at Madison. She's something wrong with the legs.
What?
I don't know. All right. So I want you to take 30 seconds, and you're going to try example 1. Let me explain it first. Determine which postulate, that's SSS or SAS, if any, can be used to prove that the 2 triangles are congruent. So you're going to look at these 2, and you're going to say, yes, they're congruent by SAS, yes, they're congruent by SSS, or you can say, I don't think they're going to be congruent based on what is given. And so you're going to write none. Then you're going to do the same for B and the same for C. So write SAS, SSS, or none after looking at the diagram. Take about 30 seconds. done, you can set up that proof below too. No. I'm good with that. No, like you're given triangle or something. Right. But that's a good point. You sometimes you're provided as a triangle that you see, you know. They'll give you other information about the triangle. We can take a few more seconds to finish up, and again, if you're done, just set up the proof. So let's see. Let's see how you did on A, B, and C. So how about? I think I'm joking too much. How about? Let's go with Cat over there. What'd you say for A?
Side angle side.
You said side angle side, as in SAS. Do you guys agree?
I agree.
Sure.
Yeah.
I do agree. Yeah. You have here's one pair of sides congruent. Here's another pair of sides congruent, and there's a pair of angles, and the angle is included for each of those. So sounds good. Let's go B. Yes. How about Adriana? Well, actually, SSS. You don't have this. It's not marked. If it's not marked, we can't conclude. So like they would have had to put this there. Then you would know all three sides are congruent. So if it's not marked, we do not know. So I'm going to erase that. Somebody else? Cynthia? SAS.
Because you got the angles that are congruent with the two sides.
Is, what did you say? Not the same angles, yeah. So good try. We went through all of them. It's none. That's what you thought, right? Because this angle, so this one works. It's two sides and that angle is included. However, here the two sides are there. The angle would need to be that one, and it's not. It's none. Because you don't have three sides, so you can't say SSS, and the angle is not in the right spot. That's the problem. So it's none. Last one. How about Madison, birthday girl?
I think that they are SSS.
SSS, you guys agree?
I agree.
I only see two sides congruent though.
So if there's two sides that are next to each other, it's the same side.
The same side, we know are going to be the same length. Good job. Questions on that?
No.
So if you set up the proof, or you can right now, we will do one proof and then let you guys work on the practice. So let me set it up here. This is, so we're going to show these two triangles are congruent, which is what we're going to be doing a decent amount moving forward. So we got Ja congruent to Za, and A is the midpoint of segment DM. It's marked on the diagram, as much as we know. And we're going to show the triangles are congruent. So now we don't need all 6 parts. We're just looking for one of these, SAS or SSS. And just as a quick reminder, you do not, that's all we need, segments congruent. You're not going to change them to an equation. Just leave it at that. All right, so here's a vocab word. We haven't done this one. We haven't used it in our proof yet. A is the midpoint of DM. And if it's the midpoint, then it's right in the middle, making the segment lengths the same. By the way, somebody earlier asked a good question. They said, are midpoint and bisect the same? And I'm like, well, they're basically accomplishing the same thing. Right? If they say midpoint, it makes congruent segments. If they said like there was a line that bisected, it also makes congruent segments. So it kind of gets to the same thing. Okay, but they specifically said midpoint, so that's what we're going to do here. So, da congruent to ma. Oh, and so I want to mention here two things. Right now, I'm fine if you want to say it was a vocab word, definition of midpoint, or if you want to write midpoint theorem. So let me say this. This is actually technically the correct one, because this one says the segments are congruent, and this one says they're equal. Okay, this actually says DA is equal to MA. This one, the theorem actually says they're congruent. So technically it's this one. Right now I'm alright if you just put definition of midpoint. I think they're both would be acceptable on the test. Oh, and I marked my diagram. Please make sure you put the slash marks in. Good so far? So I mentioned it a few minutes ago. If you have bow tie triangles, which we do, vertical angles, yeah, every time. So you
use that as like a reason?
Yes.
Type thing?
Oh no. The reason is vertical angles theorem.
Okay, well, yeah.
Yeah, but you can just identify if they're bow tie, you're going to do vertical. So that was Jad and Zam, angle JAD. Can't say A. So you gotta say JAD and ZAM. They were vertical, and so we can write vertical angles theorem. Okay, and again, the reason I'm marking my diagram is so I know when I'm done. Okay? I don't have 3 sides congruent, I'm not going to be able to, but by marking this, I say I have 2 sides congruent and the included angles. Therefore, I have enough information to say the triangles are congruent. So I'm done with the setup. Now I just need to state in step 4 that the triangles are congruent. The triangle JAD is congruent to triangles. Okay, and the reasons are, oh, I already put them up. The new postulates. So SSS or side angle side. And certainly this one is SSS. Okay, so if you write, this is important, if you write this to the left, you needed to say the triangles were congruent by SSS or SAS. Alright, good stuff. So really, I mean, just, you know what, the SAS is really the only new one in this. We've done vocab before, we've done vertical angles. The SAS is the new part. That's all I'm going to do. I'm going to let you work on 1 through 9 on the practice. 1 through 6 is just identifying SSS or SAS. 7 through 9, 3 practice proofs like this one. What questions can I answer?